We are finishing up circles today. Chapter 10, Section 9, on lengths and areas of sectors. Arc lengths and areas of sectors. You not tired of circles yet? We'll see. See if I can get this to advance. Okay, arc length. What do we mean by arc length? That's different than the arc measure. Okay, the length of part of the circumference. You remember what circumference means? Circumference is the distance around a circle. Okay, the distance all the way around the circle. So it's a portion of that circle. Okay, arc length. So here's our circle. It's a portion of that distance all the way around the circle. Okay, it's an arc. You know what an arc looks like. But the length is actually a measurement, say in centimeters or in inches, something that we would use to measure length. Okay, we're not talking degrees here. It's different than the arc measure. Okay, the length of the arc depends on what? Two things. What do you think it depends on? How would I make the length of this arc longer or shorter? I could change the size of the circle, and I could change the number of degrees that that arc was. So the measure of the arc, meaning the degree. So instead of saying, okay, let's find the center here. Instead of defining this arc with these two radii, I could define it with these two radii, and my arc length would change. Or I could use a smaller circle, and my arc length would change. This is a lot shorter than this one. Okay, so it depends on those two things. Again, remember, we're measuring in things like inches or centimeters. It'd be like we were actually measuring the length with a ruler. Okay, so it's the length is actually like centimeters, inches, that kind of thing. The measure is degrees. You got to keep those things straight. And I know that that is confusing. Okay, so an arc length measures distance, while the measure of an arc is in degrees. You need to know that. You should be writing that down in your notes right now. Stop the video and copy that down. And write in whatever details you need to, pictures, whatever it takes. You know, put in centimeters, inches here, and degrees here so that you know the difference. Because that's a big stumbling block right there if you don't. Okay, what is the sector of a circle? A sector of a circle is a region bound by two radii and an arc. So what does that look like? Here's our circle. Here's two radii. There's the arc between it. So that whole piece of the pie, piece of the pizza, that's a sector. Okay, think of it as a piece of the pizza. A piece of pizza or a piece of pie. It's called a sector. Okay. So let's do some problems of the three different types. When we're talking about arc measure, again, this is degrees. We learned that at the beginning of the chapter, that it's the same as your central angle. But if we have a portion of a circle, like if they just tell you a fourth of a circle or half a circle or a third of the circumference, whatever, you should be able to figure that out. You should know these portions, these fractional parts. How many degrees is in an entire circle? Remember, the whole circle equals 360 degrees. So a fourth of that circle, you're just going to divide that 360 by 4, and you know that that central angle is 90 degrees. Therefore, the arc measure is 90 degrees. Remember, arc measure is degrees. It's the same as the central angle. What is half a circle? Half of 360 is 180. So your arc measure is going to be 180. Okay, this is all review. Just want to clarify terminology here. A third of your circumference. Doesn't matter how big your circle is. If it's a third of the circle, it's a third of 360, which is 120. Now, this last one, 60 out of 360. You could write that as a fraction, but you always want to reduce. Your zeros cancel. 6 out of 36 will reduce to 1/6. So this is 1/6 of your circle. Well, 1/6 of 360 is 60. Okay, so these are some fractional parts that you need to become familiar with, because we're going to be using these fractional parts to determine the length of arcs and the area of circle segments and sectors. Okay, so area of a sector. Okay, remember, it's a piece of the pie. It's a piece of the whole pie, the whole pizza. Okay, we just want to know this portion. Well, how do we find the area for the whole thing? Do you remember the area formula? It's right here, pi r squared. That would be the whole thing. But if I just want a fractional part of it, guess what? I'm just going to multiply by that fractional part, and that gives me the area of that little piece. Well, this fractional part is determined by the angle measure here. Okay, if that were 30, if I told you that this central angle was 30 degrees, the fractional part of this entire circle is going to be 30 degrees over the whole thing, 360, times pi r squared. There should be a squared here. Okay, so there's my little fractional piece. The whole thing is pi r squared, but the piece of the pie is your fractional part. You're just going to multiply the two together. Okay, so the area of the sector is your fractional piece, your degrees over the whole, 360, times the entire area of the circle, pi r squared. Write down this formula. You need to know that. Again, pause the video, write down any little pieces of information you need to clarify, draw the picture, whatever it takes to help you remember and give you something to refer back to. The arc length formula. If we were to measure the length in inches or centimeters, how would we do that? Well, remember, if we have our entire circle, oh no, that's not, the arc length, say from point A to point B, is a portion of the circumference. Well, what was our circumference formula? 2 pi r. So I just want the fractional part of that entire circumference. I don't want the whole thing, I just want this part. Okay, well, this part is related to however many degrees my central angle is. It's the same fractional part, only this time we're taking the fractional part of the circumference formula. Okay, so the measure of your central angle or arc over the whole, 360, times your circumference will give you the length of your arc. So the formulas are almost exactly the same. It's just that one is a fractional part of the whole area, pi r squared. The other is a fractional part of the circumference, 2 pi r. Okay, so let's do some problems here. Ooh, this looks overwhelming, doesn't it? Find the length of arc AB and the area of sector AOB. So this is our O here. So we have an angle and it has a measurement of 90 degrees. So what fractional part of that entire circle is 90 degrees? You should know that, I'm sure, just by thinking about it in your head. The fraction of the circle is 1/4. It's 90 over 360. 1/4. So we're going to use that in both formulas. Now, if we're finding just length, just arc length, remember, that is a portion. It even shows you the symbol. That's a portion of the circumference. Remember, the whole circumference is all the way around. So we want 1/4 of the entire length or distance all the way around that circle. So we're going to take that fraction here, and we're going to multiply it by the circumference, which remember is 2 pi r. Well, if our radius is 6, as it tells us here, we drew it in, we're going to double that because it says 2, so that's 12, and then just leave pi in your answer. What's 1/4 of 12? 12 divided by 4 is 3 pi. Leave pi in your answer. Totally acceptable, and it is the most accurate way to represent a measurement. Now, if we do the area of that sector, it's the same fractional part. It's still 1/4 of the circle, but this time we want this whole area. So we've got to multiply that 1/4 times our area formula, which is pi r squared. Don't get circumference and area formulas mixed up. Pi r squared. So 1/4 pi r squared, we got to take this radius and square it. What is 6 times itself? 6 times 6 is 36. What's 1/4 of 36? 9. Again, leave the pi. Leave the pi in your answer here. And box it in. Okay, so let's go on to this one. Fractional part, 240 over 360. Can I reduce that? Well, my zeros cancel. Can I reduce 24 over 36? What number goes into both of those? I see a 12 in both of those. 12 goes into this 2 times. 12 goes into 36 3 times. So I get a reduction down to 2/3. So the fraction of the circle is 2/3. So to find the length, I'm going to take that 2/3, okay? Let's plug in what we know. From A to B is 240. We have a radius of 12. So we're looking for this big arc right here. The length of it, 2/3 times the circumference. What's the circumference formula? It's 2 pi r. So here's my fraction. If my circumference is 2 pi r, what's 2 r's? 24, with a pi next to it. Now to reduce, what's 24 divided by 3? 8 times 2, 16. Leave pi in your answer, 16 pi. Now let's do the area of the sector. Again, we're trying to find the area of this whole sector here. Same fractional part, but it's a fractional part of the whole area, which is pi r squared. So I'm going to do my fraction times my area. Well, if this is r, what would pi r squared be? What's 12 times 12? 144. So I'm going to get 2/3 times 144 pi Again, reduce, divide by 3, multiply by 2, and you get 96 pi. Don't forget your pi. If you don't put pi in there, it's wrong. Pi is a number. It's 3.14, and so on. Okay, let's move on to number 3. What am I going to put this over? 300 over what? The whole thing. Can I reduce? Does anything go into 30 and 360? A 3 goes in, that would be 10 over 12, and I can reduce that to 5 over 6. 6 goes into both of them. Okay, so my fractional part is going to be 5 over 6. Okay, I'm going to take that fractional part and multiply it by what? To find the length. I want to multiply it by the circumference. Well, circumference is 2 pi r, right? 2 times r is 24. So that's where the 24 pi came from. 24 divided by 6 is 4 times 5 is 20 pi. The area is going to use the same fractional part times its area. So what's the area going to be? Pi r squared. What's the area of this circle going to be? 144. Divide by 6, multiply by 5, 120. Okay, pause the video. Try to do number 4 on your own. See what you come up with. Okay, let's see how you did. So if I take this 120 and divide it by 360, I get 1/3, so my fractional part is 1/3. I multiply that by 2 pi r. Well, 2.4 times 2 is 4.8 pi. So 1/3 times 4.8 pi. And I get 1.6 pi when I divide by 3. Again, use a calculator. Same fractional part times the area, which is pi r squared. Okay, I'm sure you had to do that on a calculator. 2.4 times 2.4, 5.76. If I divide that by 3, 1.92 pi. Don't let decimals throw you. You can punch a decimal in a calculator just like you can punch a whole number in a calculator. Okay, what's the fractional part of 108? 108 divided by 360. What did you get there? Pause the video and figure that out. 3/10. A calculator should be able to reduce fractions. And I know this one has a lot of different looking things in it. 10 square root of 2. Just treat that like a number. Okay, so I'm going to plug all this in. My radius is 10 square root 2. I need to double that, so that's going to be 20 square root 2 times my fractional part. 20 divided by 10 is 2 times 3 is 6. Now, here's something you might not remember. When you square, I need to square this radius in the area formula. You got to square this and you got to square this. 10 squared is 100. Anytime you square a square root, it's like getting rid of both, right? So this ends up just being times 2, whatever's inside. You square a square root, you get whatever's inside. What's 100 times 2? 200. So we're going to take our fractional part, 3/10, and multiply by 200 pi. Don't forget your pi. Now what is 200 divided by 10? 20. Times 3? 60. With a pi next to it. Okay. Make sure you are asking questions about this when you come to class. It's all about finding the fractional part, knowing your circumference formula and knowing your area formula. If you can do those three things, you can set these up. Now, here's something that might be thrown at you. What if I wanted to know the area of this portion? What would you do? You know the area of this portion, this sector. There's a couple of ways you could approach that. You could find the area of the whole circle, pi r squared, and subtract, or you could subtract from the beginning. You know if this is 120 degrees and this is 240 degrees. And then use this as your fractional part. We'll do some like that together. Okay. Again, I would pause right here and I would see if you can figure this out. This is a challenging one. You're given different parts. This time you know the area of the sector is 48. So here's our formula. This time you know the area. You know your arc measure. You're looking for radius. This is what you're looking for this time. So far we've been looking for this, but we can use the same formula and just solve for the missing part. We plug it all in. If you have the same thing on both sides, whether it be an x or a pi or whatever, if you're multiplying and you have the same number on both sides, you can cross them out. So a pi on both sides, we can cancel out. We're going to reduce that fraction. And now we have to get rid of the fraction. This is where y'all are going to struggle. Remember, the top of the fraction is multiplication. The bottom of the fraction is division. If I want to undo this division of 4, what's the opposite of dividing by 4? Multiplying by 4. So a 4 on top is going to undo a 4 on bottom. How do I undo multiplying by 3? What's the opposite of multiplication? Division. So I'm going to divide by 3. A 3 on the bottom will undo a 3 on the top. So all I did was flip this fraction. Hopefully this is starting to look and sound familiar. You did this in algebra last year. You multiply by the reciprocal. What I do on the right side of my equation, I must do on the left side of my equation. So here's my reciprocals. Okay, my 3's will cancel out here, and my 4's will cancel out here. If I divide 48 by 3, here, I get 16. Times 4, I get 64. Okay, so there's my 16. Times 4, I get 64. Everything over here on the right canceled out, so all I was left with was my r squared. That came straight down. How do I get rid of this squared? I take the square root. I can do that in a calculator. You should know that 64 is a perfect square, so the radius of this circle is 8. Okay, here's another challenge. An area of a sector. Okay, well, let's start off with that area of a sector formula. Always start off with your formula. Write it down and plug in what you know. I know that the whole area is 9/4 pi. I know that the measure of my arc is 40. I'm looking for radius. So very similar to what we just did. We're going to plug in those parts that we know, and we're going to work the problem algebraically. I have pi on both sides, so I can cross that out. I'm going to reduce my fraction. Remember, zeros on the ends cancel. 4 will go into both of these. 4 goes into 4 one time. It goes into 36 9 times. Okay, so I end up with this. How did I get rid of this 1/9? Remember, I need to flip it. I need to find the reciprocal, multiply both sides of my equation by that reciprocal. If I have the same number on top and bottom, I can cancel. Can't cancel here. Not when they're side by side. I have to multiply here. Okay, so I'm going to do that. I'm going to multiply and I get 81 over 4 is r squared, because see, I didn't cancel that out. That came straight down. Now I need to take the square root. I'm going to take the square root of both parts. What's the square root of 81? And what's the square root of 4? Leave it as a fraction. So r is going to equal 9/2. Lots of calculations today. Okay, but again, it's just working the problem. All you really need to know that's new are your two formulas. You should know how to find a fractional part. You should know how to reduce fractions. And you should know how to multiply by reciprocals to get rid of those fractions. So really the only thing new is the formula for the area of a sector and the formula for the length of an arc. So make sure you have those written down. Okay, here's some common fractional parts. You might want to write this down just to refer back to if you want to, if you're not good at reducing fractions. Okay, 36 degrees is 1/10 of a circle. 60 degrees, I'm sorry, let's go across. 109 is 3/10. 108 is 3/10. Ugh. 60 degrees is 1/6. So 5/6 would be 300 degrees. Notice the relation here. Okay. 36 is 1/10. 108, which is 3 of those, is 3/10. 60 degrees is 1/6. So 5 of those is going to be 300. That's 5/6. 120 is 1/3. So what is 2/3 going to be? 240. 30 is 1/12. 11/12 is 330. What is 1/8? 45 degrees. So 5/8 is going to be 225. Okay, these are just some common ones you might see that'll help you if you have this chart available. But unless you're going to memorize this chart, you need to learn how to do it on your calculator, because I'm not giving you this chart on a test. Okay, come in with questions. Work some problems on your own. Be prepared for class. See you then.